so now that we've learned about molarity and concentration of solutions, in this lesson you're going to learn how to actually make those solutions. So there are two situations I could be in. In my prep room, if you go to the back of my room, in that room in the back, there are substances, and they can either exist as solids or they can exist as solutions. And so if I want to create a specific solution that has a certain concentration, the way that I make those solutions is going to be different depending on if I have a solid versus if I have a solution already, a concentrated solution. So the first thing I'm going to explain is how to create a solution if I start with just a solid. So keeping in mind for this type of a problem, I need to use my formula, molarity equals moles of my solute divided by liters of solution. But do keep in mind that while we're talking about moles here, remember, I cannot measure moles in the lab. And so what I'm actually going to have to measure and what I'm going to have to determine here is how many grams of my substance I need to weigh out first on an electric scale. So for the first example, it says, explain how to create an 105 ml sample of a 1.02 molar glucose solution. Okay, so I know my molarity, it's 1.02. I'm going to be solving for my number of moles because I don't know what that is. Okay? And I know my volume. Keep in mind, your volume needs to be in liters, but right now it's in milliliters. So I need to convert this from milliliters. And I'm going to do that by putting milliliters on the bottom and liters up top. 1 mil is 10 to the negative third liters. Okay? So what this is going to give me for my volume is 0.105 liters, just like what we were doing before. Okay, and then in order to calculate my moles, what I'm going to have to do is cross multiply. So I'm going to put 1.02 over 1, and then I'm going to cross multiply and cross multiply. So what that tells me is that my x, which is my number of moles, is 1.02 times 0.105. And what I get, unrounded, is 0.1071 moles. Okay, that's great. However, I can't measure moles in the lab, so I need to convert this into grams. So I'm going to put moles on bottom, and I'm going to put grams up top. Okay, grams to moles, or moles to grams, I need to use my molar mass. So I need to determine the molar mass of C6H12O6. Okay. The molar mass of carbon is 12.011. I've got 6 of them, so I'm going to multiply by 6. Then I'm going to add to that the molar mass of hydrogen, 1.008 times 12, because I've got 12 hydrogens, plus the molar mass of oxygen, 15.999 times 6, because I have 6 of them. So the molar mass of glucose is 180.156 grams for every 1 mole. Okay? And so what that then tells me, when I multiply by my number of moles, which was 0.1071, the mass is going to be unrounded 19.29. Figure out sig figs. 105 has 3 sig figs. 1.02 has 3 sig figs. So I need 3 sig figs. So this is going to be 19.3 grams. Okay, but this isn't the answer because it says explain how to create this. So what you're going to have to do is you need to weigh your 19.3 grams of glucose on a scale. Okay, and then you're going to add it to a container such as a graduated cylinder, and you are going to add it and then add enough water to get a final volume of 105 milliliters. Okay, and so just as a quick review, by weighing out 19.3 grams of your glucose, adding it to a graduated cylinder, and then adding enough water to get 105 mils, that 105 mils is the volume of the total solution, which is our definition of molarity, right? The volume of the solution. Okay, so if I do that, add 19.3 grams, then add enough water to get a final volume of 105 mils, then the solution that I've created will have a concentration of 1.02 molar. Okay, and that's all there is to it. So let's try one more practice problem. If what I start with is a solid. Okay, so it says, explain how you would make a 1.5 molar solution of copper sulfate with a final volume of 150 mils. So again, I'm going to be using my formula. Molarity equals moles of solute over liters of solution. Okay. 1.5 is my concentration. I don't know my number of moles. Okay. And again, my volume of my solution needs to be in liters. So I'm going to take it from mils. And again, if you can recognize that to go from mils to liters, you just have to move your decimal place 1, 2, 3 places. Awesome. If you're not comfortable with that, you can totally do the same setup that I'm doing right now. Okay, but you end up getting the same thing. 150 is my liters. Okay, so I'm going to plug that in here, and that will tell me my moles of my solute. So I'm going to take 1.5, and I'm going to multiply it by 0.150, and for my number of moles, I get 0.225 moles. Okay, perfect. However, I can't measure moles in the lab, so I'm going to have to get out of moles, and what I can measure with respect to mass is my grams. Okay, so the only issue here, I need to know the molar mass of copper sulfate. So the molar mass of copper is 63.546, the molar mass of sulfur is 32.066, and the molar mass of oxygen is 15.999, but I need to multiply that by 4 because I have 4 oxygens. And so the molar mass that I get of copper sulfate is 159.608 grams for every 1 mole. So then what I'm going to do is take my number of moles, 0.225, multiply it by my molar mass, and the mass that I get is going to be unrounded, 35.91. Keep in mind 1.5 has 2 sig figs, 150 has 2 sig figs. So this is going to be 2 sig figs, so this is going to round to 36 grams. Okay, so steps that I need to take to make this solution. First, you're going to weigh 36 grams of copper sulfate on a scale. Okay, then you're going to add it to a graduated cylinder, and then add enough water to get a final volume of 150 mils. All right, so I just showed you how to make a solution if you have a solid and how to use that solid, how to measure it out on a scale in order to create a solution. What if instead I want to make a solution and what I have in the back of the lab is actually a concentrated solution? What do I do then? Well, then you're going to do a dilution problem. And so the formula for a dilution problem is actually quite simple. All that you have to do is say, okay, the molarity of my first solution times its volume is going to be equal to the molarity of my second solution times its volume. Okay, so the best way to explain this is with an example. Now the picture that I showed here, I purposely showed it here because what we're going to be doing is we're going to figure out, okay, what volume of my concentrated solution do I need? And then we're going to add enough water to get our final volume. Okay, so we're going to be measuring instead of measuring the mass like we did when we made a solution from a solid, we're going to be measuring the volume of our concentrated solution that we need. Okay, so using the dilution formula, let's look at this first problem. It says, describe how you would make 2.5 liters of a 0.100 molar KCl solution from a 5.5 molar stock solution. So a stock solution, all we're saying is, hey, this is a concentrated solution. Okay, so it doesn't matter what you make your M1 versus your M2. So I'm going to just make this my M1. This is what I want to end up with, the concentration, 0.100. Just make sure that the volume your V1 matches with the correct concentration. So I want 2.5 liters of that concentration, so this is going to be my V1. And so the question becomes, okay, what volume of my stock solution do I need to measure out? This first step of pouring in your concentrated solution. So let's determine that. M1 V1 equals M2 V2. So my M1 is 0.100. Okay, my volume is 2.5 liters. Okay, my M2 is 5.5 molar. Okay, and I'm solving for my V2. Okay, so let's do that. So I'm going to take 0.100, multiply by 2.5, and then I'm going to divide that by 5.5. And for my V2, let me scroll down. For my V2, I get 0.0454. Okay, and my units are liters. Okay, let's figure out sig figs quickly. 2.5 has 2 sig figs. 1.00 has 1, 2, 3 sig figs. So I want 2 sig figs here. Okay, so this is going to be 0.045 liters. Okay. Keep in mind, I know this is liters because my unit for volume here was in liters. Instead of using liters here, I could have also used mils. So if the volume is given to you in milliliters, you can plug milliliters in here. It just means that your V2 will be in milliliters as well. They just need to match on either side. Okay, so as far as instructions are concerned, you're going to measure out 0.045 liters using a graduated cylinder. Okay, and then you're going to add enough water to get a final volume of 2.5 liters. And let me really quickly note, I want to measure 0.045 liters of my stock solution. Okay, because I need to specify what exactly I am measuring. So you can say your stock solution, or if you want to say of your 5.5 molar solution, that's fine as well. So I'm just going to abbreviate solution. Okay. All right, let's look at one last example. It says, describe how you would make 3.5 liters of a 1.2 molar NaCl solution from a 6 molar stock solution. So this is going to be my V1. This is my M1. That's the concentration. That's the volume that I want. And this is my stock solution. So this will be my M2. So I need to determine the volume of my stock solution I need first. So it's going to be M1 V1 equals M2 V2. M1 is 1.2. V1 is 3.5. Okay. And M2 is my stock solution concentration, so 6.0. Okay. And then my V2 is what I'm solving for. All right, so to solve for this, I'm going to take 1.2, multiply by 3.5, and then divide by 6, and that gets me my volume. So my V2, which is what I'm solving for, is 0.7. That's what's given to me. And so what I'm going to need to do is I need to add a sig fig, actually, weirdly enough, because I have 2 sig figs from 3.5 and 2 from 1.2. So the volume I need is 0.70. So I can have 2 sig figs. And my units are liters, simply because this volume here is in liters. If this volume were in milliliters, then the 0.70 wouldn't be in milliliters. Okay, so steps. I need to measure 0.70 liters of my stock solution using a graduated cylinder. Okay, and once I measure that out, then I need to add enough water to get a final volume of 3.5 liters. Okay, so as a quick review, you're taking a stock solution, 6.0 molar. You're measuring out how much of it you need, 0.70 liters of it, using a graduated cylinder. And then you're going to add enough water to get a final volume of 3.5 liters. By diluting it with the water, you're creating a solution that has a volume of 3.5 liters and a concentration of 1.2 molar.